Here I'm going to demonstrate cross country from Lino up to Hamilton via VFR direct. So we're just going to make a straight line up that way. I've already drawn the line. So my next thing I want to do is come up with the visual update points that I'm going to use to make sure I don't get lost and have something to dead reckon off of for the flight plan. So we're going to start with this video, everything that I can do the night before, follow that up with all the calculations that I would do when it's time to start putting in the weather and determining our ground speed and wind correction angles. And we can start that as early as 6 hours prior to our scheduled takeoff due to our ability to get a standard weather briefing, which is the most comprehensive weather briefing available and really helpful as far as interpolating the winds at different flight levels and giving us a good solid picture of what to expect. So the idea, we're going to take off from Lano, and this is just pretend, of course. I'm going to find something just past probably 10 miles or so, give myself some time to climb up. Because what is going to happen with this is we're gonna take off from the airfield, and we're gonna climb up to an altitude, and we're gonna level off at that altitude. So the whole time we're climbing, we're subject to kind of an average wind, and wind is going to determine what our ground speed is, of course. So we're going to get winds at, let's say, 3,000, 6,000, 9,000, 12,000, and so on. All right, so for Lano, if we read the box, this number here in the italics is our field elevation, 1102. So this is going to be 1102, and then this is going to be our level off altitude. Now I'm seeing that this is largely a northeast heading, and you can see this line here is our variation. So the variation is only 4.5 degrees here, so we're going to round up to 5, because if we look at the very center of our route, it's just a little bit to the left of this, and the easterly variation at this time increases as you go toward the west. So if this is already 4.5, then it's going to be 5 at that midpoint. And whatever that midpoint is, that's going to be our average variation for the whole thing. So we don't have to change our heading just because our magnetic variation changes. And by the same token, I'm going to calculate our true course based on this line right here, which is the closest one to our midpoint. So if I was to calculate it based on this line and then recalculate it based on this line, I would get two different true courses. But if I use the one right in the middle, it gives me a good average for the whole thing. So that's the methodology I use. So we're going to start off here, 1102, and then we're going to go up. And because it's a northeasterly course, anything from 0 to 179 magnetic course is going to require an odd 1,000 plus 500 feet for the altitude, and anything from 180 to 359 is going to be an even altitude. So we know based on just looking at this, it's going to be an odd altitude because we're going up to the northeast. So I'm going to say 5,500. So we're going to use something very close to 6,000 for our level off. And my method for figuring our climb wind is just use whatever you get at 3,000, or at least figure out what the wind is going to be halfway up, because during your entire climb you're going to be approximating somewhere around that anyway. Now I know some people will take their level off wind and then average it with their surface wind. But really, the surface wind is affected by so much ground friction that it's almost worthless when it comes to plotting your ground speed for the climb. So I have historically used 3,000 because Texas, a lot of it is low country where I have done most of my flying, even out in Abilene. 3,000 tends to work pretty good. So we'll plan on using 3,000 for the climb, and then we're going to be subject to the winds closer to 6,000 for our actual level off. We're also going to be flying a slower airspeed for the climb because we've got to build that altitude, and we're trading off our airspeed for our altitude gain. But then once we level off, we're going to accelerate and fly along at that altitude. So basically, we're going to have two different ground speeds, is the moral of this story. Until we figure out how long it's going to take us to get to this altitude, we're not really going to know how far we're going to travel. We're going to have some X of distance for the climb, and then some Y for the distance after the climb to wherever our first visual update point is. So I'm going to find a visual update point that gives us plenty of distance to get to our altitude, and then begin navigating shortly after that. So I'm going to say the first really good point, there's really not much out here. I mean, there's this stream here, but that's pretty close. There's a private, unimproved surface down here that is probably not going to show up all that well. But then again, I'm speculating. We can always look in at it. No, that's not what I intended to do. I'm going to scoot this over to the center, and I'm going to switch to aerial view after I zoom in on it. I want to see what this chap is going to look like. No, I don't want your nearby objects. So if we actually look at it and click on the aerial view, we can see, I can see the river. I can kind of see, yeah, I guess that's the field, but I wouldn't stake my reputation on it or anything. So, and it's also pretty close to our departure. So what I want to use is this river bend that's up here. And it says Bend on it, but that's just the name of that small town. Incidentally, don't use these towns for updates because they tend to be really small. Now, if they coincide with some kind of road bend or river or something like that, then maybe use it. But otherwise, you're probably not going to be able to see much if you look at that. But this river, clearly comes in pretty good. It's pretty good sized river. Now, rivers can swell and contract depending on what time of year, but if nothing else, you should be able to see the topography around where that river is. So I'm going to call this my first point. So I'm going to make a mark up here where that river is, and I use the Air Force convention of a diamond. That's what we used to use for radar targets that we were painting with the radar to figure out where we are. And now I'm going to take a measurement, and you want to make sure that this says nautical instead of statute because you don't want to end up with the wrong miles, and you definitely don't want to end up with a mixture of two different ones because that'll really mess you up. So it looks like on this, I'm going to call it 21 miles. So I'm going to make a little mark here at 21 miles. And that's right before the river bend, and there's that little bend on the right-hand side. I wouldn't want to go out much past 20 miles, but I'm assuming it's going to take us somewhere around 10 to 12 miles to climb, followed by the further 10 miles to get to our first point. And so timing on that is probably going to be maybe 15 minutes or something, where we climb up to 5,500 and then start navigating. And we'll have this river coming in from the right that might just be able to talk our eyes onto it. So that's my first 21 miles. Now the next thing here is this town of Lometa. That's going to come in real good. It's a yellow town. Yellow towns are the ones that show up after dark. That's going to be the shape that it's going to be if it's nighttime and you're just seeing the street lights. And of course, there's also a railroad coming into here, a couple of highways coming in, and a few rivers along with it. So definitely, I'm going to use the town of Lometa. So I'm going to figure out how far along that is past this 21 miles, and you know what? Actually, it's pretty short. It looks like 8 miles. So, but you know, you take what you can get with some of these. So I'm going to go. I definitely don't want to. I definitely don't want to squander Lometa because it looks like a pretty good target. So 5, 6, 7, 8. I'm going to make a little mark at 8, and then draw that. So I've got 21, and then we got 8. I usually try to keep them to between 10 and 15, but like I said, you don't want to miss out on a really good obvious thing that you can use to help you out. So the next thing I'm gonna look for something a little closer to 15, and what I've got here, there's this road here in the town of Moline. I've already looked at it on the aerial view, and it really isn't going to show up very well. But something that does is just past it, there's this river here. And it's a river with little dots in the middle of it, which means it's more of a stream. So you're probably not going to see the water until you're right on top of it. But what you will see definitively is a tree line. Because this out here is just, pastures, little squares of corn groves and things like that. But you'll see this snaking little area where there's just trees all along. So you'll see that, and you'll see another one out here. And shortly after that, there is a power line. Now, you might see it, you might not. I was always told to look for power lines by the absence of the trees. There will be a cut in the tree line where they make room for the towers. Now, that there's not necessarily a tower exactly there either. That's just to indicate, hey, this is what this is. It's not just a road. And then we've got Highway 84. So I'm gonna use this as my next point, and in fact, it'll probably be my last point because 84 is pretty close to here. That's probably about 10 miles. But we can definitely use 84 for our descent point to start coming down from 55. That's usually it's good to have some visual thing to remind you, hey, I need to start getting ready for my descent and getting down to pattern altitude. So I'm going to go ahead and measure from Lometa over to this river bend, and it looks like 14 miles. Yeah, we'll call it 14. And it'll be just right where that is. Little diamond. So the remaining distance is 16, and we ought to be able to see it. This, if nothing else, this highway here looks like 281 leads right into the town of Hamilton, which this airfield is just to the southwest of it, and there's a couple of private airfields as well. Hamilton's at 1305, so we can expect a 2,300 foot pattern altitude. unless otherwise indicated, of course. So that's going to be 16. All right, so I'm going to take this out, and I'm going to write everything in as we have it. So first point, of course, is Llano, AQO. So I'm going to put KAQO. Then the second line is going to be top of climb. I'm going to make sure I indicate that with a line. Now, I'm not going to know what the distance is. The distances go right here in this column. It says distance, leg versus remaining distance. I'm not going to know this line or this line for the distances. So what I usually do is write it out here so that the day of, I'm able to take this number and split it. So I'll figure out the distance for the first half, and then whatever remains after level off, I can write in here. So this plus this is going to give me the total distance to the point, which we said was 21, as I recall. So I'm going to come back down here and make sure I haven't forgotten something. Yep, it's 21, so I'm going to write a 21 out here. And this is the only one that I do this with, where I write the number off in the margin. But then from that to there, that was as I recall. Okay, that's the 21, and this is 8. That's right. So the town of Lometa. I'm going to put in the distance right here. Okay, so this is from. Oh no! Oh, my mistake. Okay, I wrote the wrong one. Lometa comes down here. Even I get screwed up with the top of climb deal every once in a while. In the Air Force, we called it a level off. I blame that. Okay, so this I'm going to call River Bend. Then Lometa. So the distance from the River Bend to Lometa is going to be on this line right here, and it says distance. So this is 8. There's an 8. Okay, so from Lometa to the next thing was 14. I'll write the 14 and remind myself what it is. It's a creek. I'm just going to call it creek. And then the remaining distance was 16 to the town, or to the airfield of Hamilton, which is an identifier MNZ, KMNZ. All right, so what are we doing in the meantime? Well, these VORs, I'll come back with some information about how we can use these VORs to help us out, but we're not using a Victor route. If we were, what we could do is take off, go up to the north, and catch this. It says it's Victor 161 or Victor 568. Go up here, set up the Llano Vortac 108.2, and then follow it out the 018 radial until we get to this just before built intersection up here, and then just jet over to Hamilton once we get it in sight. So if you're on this route, then you don't have to worry so much about what's on the ground or whether you're left or right of course, because your instruments are telling you that. So the other thing we can do while we're here is figure out what the true course is. So to get a true course, you go to the chart, take your plotter, and I'm a fan of the small plotters because I can use them on the ground and I can also use them in the air, and they're a lot easier to use than those big ones, especially the ones with the moving parts. But it comes down to personal preference. If you're a dedicated navigator on board an airplane and you have your own table, then one of those would be just fine. But for me, I like this one. So I'm going to look at the number before and the number after, so 020 to 030, and I ask myself, does this make sense? Well, if that's 360 or 000, then 20 degrees, that does make sense. It is possible on one of these to plot a reciprocal and accidentally think you're on a 206, but you're actually on a 026. So I'm going to call it that, 026. And your true course goes into this line right here, 026. Now our altitude for this first one is just going to be climb. We're just climbing up, and a lot of people put a 55 right here for 5,500 feet. Then after top of climb, we're going to be at 5,500, and we're going to continue at 5,500 until we get to our destination. There is going to be a descent down here someplace, but we're going to fly it as if we're still at altitude, because we're going to adjust our power to maintain a constant ground speed so that we don't end up early or late. Wind, we don't know. True airspeed, we don't know. We won't know until we get the pressure, altitude, and the temperature. So true course we do have, and I know that all of these true courses are going to be the same because it's independent of the wind. This wind correction angle, I'm going to have one for here with this wind, and then I'm going to have one for here with this wind. Now, I already know that all of these winds are going to be following the information on here. I'm not going to plot different winds. So I'm going to draw my line down here because I know that all of these are going to be the same as whatever this is. This is going to be something unique. Now I know I'm going to have a true airspeed here and a different true airspeed here, but then the rest of these true airspeeds are going to follow along. Magnetic variation I can go ahead and put in. It's -5 because easterly variation you subtract and westerly variation you add. East is least and west is best, they say. Comes to deviation, I don't know, but I do know that all these variations are going to be the same. And in fact, all of these are going to be the same as well if we have the same exact variation, and these are going to be the same because we're going to have the same wind correction angle. We're not going to slow down or speed up or anything. And if the wind shifts on us, there's no way we have of predicting that. And then we're going to have a deviation here, deviation here. The rest of that's all going to be the same. So we're going to just write that down as well. And then all of these compass headings are going to be the same. We have our distances. I'm not going to really calculate our leg. I mean, I could say 21, 29, all that stuff, but I'll total that up and write it down later. Now, these are the ground speeds, so I know this is going to be a different ground speed from this, but this is going to be the same as this one. So I'm going to go ahead and put my check marks as well. We call this gouging up the log. You put in as much information as you possibly know that you're going to have in the log so that come the day of, you barely have anything to write in at all, actually. So time off, gallons per hour. I already know the gallons per hour for this airplane because I can get it from the performance chart. And if I can take a second and get my password in, which you don't get to look at. Macintoshes, they just work, don't they? All right, so I have a POH here. This is the time to climb, but we also have speed power. So where you see the previous line, and I've got everything oriented 90 degrees off, engine performance, this tells you how much RPM you need to produce for 75% power. It looks like we will probably be able to make 75% power with about 2550 RPM if we can swing that. Unless that's that's a 6,000, so that's 55. So over here, yeah, it's just going to be 2,500. So we'll be able to get 75% power, it looks like. So at 75% power, we get 6.5 gallons per hour burned. So that's what I'm going to put. Everything's yellow for a second. Okay. So I'm going to go ahead and put 6.5 in here. And even if we don't get 75% power, we know we're not going to burn more than 6.5 gallons per hour. And then I'm going to use this to calculate all our fuel in this column here. Our fuel is going to be based on our ETAs and all that other stuff. So now from here, we can get all our frequencies and things right out of the other document, which is the chart supplement. So Leno Municipal, we don't have an ATIS, but we do have an AWAS 3, 119.425. It's right down there, 119.42. We don't have ground frequency or tower frequency. We have a CTAF because there is no tower. So CTAF is 122.8. Communications, Houston Center approach and departure control, 132.35. We can put that in, 132.35. And we also see, is there a nearby flight service station? Didn't look like it on here, but there is a communication outlet out here, Lampasas, RCO, I assume. So you would be talking to San Angelo, 122.55. So I'm going to write that down here, 122.55, and that's where that goes. Unicom is the same as CTAF, 122.8 for here. Field elevation, we already figured, 1102. Block in, block out, we don't have that stuff. So ground and tower frequencies are irrelevant. Departure, KAQO, and KMNZ. So that's frequency block. I'll have the rest of these written in. This you don't actually write in until you start your engines, because these expire after every hour. And that's all we've got so far. So we're all gouged and ready for the next day's work. I'm going to go over how to get the weather and how to get the briefing and where to get your performance data, and then we'll work through all these calculations on the E6B flight computer, or the military MB4, collectively referred to as the whiz wheel.